Let's look at doing 3 easy molar math skills. And this goes along with our unit on atomic theory and the mole. Moles and molar mass. A mole is a definite number of atoms or molecules or formula units. It's like a dozen. But unlike a dozen, it's a very, very large number, and it rounds to 10 to the 24th power. But the atom is so very, very small that 1 mole of oxygen gas, or actually any gas, fits into 22.4 liters at 0 degrees and 1 atmosphere. That's called standard temperature and pressure. The molar mass is the mass of 1 mole of a substance, and it's a very important quantity in chemistry. We can get the molar mass of a compound from its formula. If you have the formula of a substance, you can calculate the molar mass if you have a periodic table or another table of atomic masses. So if you have a table of atomic masses or a periodic table that has atomic masses on them, you can do this. For instance, we know water is H2O. It has 2 atoms of hydrogen for every atom of oxygen, which means it has 2 moles of hydrogen atoms to every 1 mole of oxygen atoms. Now, a mole of water has 2 moles of hydrogen atoms and 1 mole of oxygen atoms. Therefore, with hydrogen at 1 gram per mole and oxygen at 16 grams per mole, we add 2, which is 2 times 1, 2 hydrogen atoms times 1 gram per mole, plus 16 grams per mole for the 1 oxygen, and we get 18 grams per mole for water. And all we needed was the formula and the atomic masses of the 2 elements that make up the compound. So it's your turn. Find the molar mass of carbon dioxide, knowing carbon on the periodic table is 12 grams per mole, and each mole of oxygen atoms is 16. Find the molar mass of HCl. Hydrogen is 1 gram per mole, chlorine is 35.5. And find the molar mass of aluminum hydride, aluminum being about 27 grams per mole and hydrogen being 1. So go ahead and turn off the video, work it out, and then check your answers. The molar mass of carbon dioxide, 1 times 12 plus 2 times 16, is then 44 grams per mole. The molar mass of hydrogen chloride, with hydrogen at 1 and chlorine is 35.5, is 36.5 grams per mole. The molar mass of aluminum hydride, with aluminum at 27 and hydrogen at 1, you multiply the 1 times 3 and add to the 27, you get 30 grams per mole. The second skill that you need to know is the percent composition of a compound from its formula. All you need is the formula of the substance and a table of atomic masses. You then divide the total amount of each element in the compound by the total mass of the substance and multiply by 100. So, looking at carbon dioxide, we just figured its molar mass, it's the mass of 1 mole of the carbon dioxide, is 44. In there we have 12 grams of carbon for every 44 grams of carbon dioxide. 1 mole of carbon atoms for every 1 mole of carbon dioxide molecules. So we take the 12 for carbon and divide it by the whole, 44, multiply by 100, and we get 27%. Your turn. Try it. The percentage of hydrogen in water, you already know the individual atoms. The percentage of hydrogen in hydrogen peroxide, H2O2. And the percentage of calcium in calcium chloride. You already know chlorine is 35.5. Calcium is 40 grams per mole. So shut this off, do the work, and then check your answers. Percent of hydrogen in water, the molar mass of water is 18 grams. There are 2 hydrogens, 2 moles of hydrogen atoms, so we take 2 grams, we divide by 18 grams, and we multiply by 100 for the percent. We get 11%. We then do hydrogen peroxide, which, remember, when it reacts it gives off oxygen. We add 2 hydrogens and 2 oxygens, we get 34 grams. We then divide the 2 grams of hydrogen by 34 grams of the total compound mass. For the hydrogen peroxide, we multiply by 100 and we get 5.9%. So there's more oxygen in hydrogen peroxide, gram for gram, than there is in water, which helps us to understand why hydrogen peroxide poured on a cut gives off oxygen gas to kill bacteria. The percent of calcium and calcium chloride, the molar mass, we add the 40 of calcium to 2 calcium of the chlorides, which 35.5 times 2 is 71. We add that up to 111 grams. We divide the 40 grams of calcium by 111 grams, multiply by 100, and we get 36%. The third easy skill is the percent composition from lab data. This is the easiest skill of all. You're given lab data, and you just divide the part by the whole and multiply by 100. So, for instance, if you burn magnesium and oxygen, you get a magnesium oxide. And this tells you that 2.4 grams of magnesium is burned in oxygen, forming 4.0 grams of magnesium oxide. What's the percent of magnesium in magnesium oxide? Well, you take the 2.4 grams, the part, you divide by 4.0 grams, the whole, you multiply by 100 and you get 60%. Just as simple as it can be. If you take 3.2 grams of sulfur and burn it in oxygen, you get 6.4 grams of sulfur dioxide. What's the percent of oxygen in sulfur dioxide? Well, you subtract the whole 6.4 grams of the sulfur dioxide minus 3.2 grams of sulfur, and you see that there's 3.2 grams of oxygen remaining. You take that mass of oxygen, divided by the 6.4 grams of the sulfur dioxide, multiply by 100, get 50%. That means that in sulfur dioxide, half of the mass is oxygen and half of the mass is sulfur.